Greetings, Mrs. Blaylock here. 1.4, Measuring and Classifying Angles. This is part of Unit 1 in Geometry Essentials, and the unit standards have been posted for you or shared within your class. Specifically, 1.4 is going to talk about measuring and classifying angles. And by the end of this lesson, you should be able to use a protractor to measure an angle, classify angles as acute, right, obtuse, or straight, apply the angle addition postulate, find angle measures using algebra, identify congruent angles, and define an angle bisector. So the first thing I'm going to talk about are how to measure angles. Angles are measured in units called degrees, and when we write the measure symbolically for the angle below, it looks like this. The small m we say is measure. This symbol means angle, and then we're going to use 3 points, point A, point O, and point B. Points, again, are capital letters, equals 140. This small little circle represents degrees. So here's a picture of a protractor, and the angle goes from point A to O to B. And if the rays were extended so that the bottom of the protractor touches one of the rays, and the center of the protractor touches the vertex of the angle, point O, and the angle extends out, this is measured on the protractor as an obtuse angle. So we start at the ray that lines up at the bottom of the protractor, and we follow the degree measures on the protractor until we find where the ray intersects another place on the protractor. In your book, postulate 3 says consider line OB, there's double arrows on the top, and a point A, another capital letter, on one side of line OB. So here's line OB. The rays of the form OA from O through A started at your end point, went in the direction of A, that's why we have one arrow to the right, can be matched 1 to 1 with the real numbers from 0 to 180. 180 would be a straight angle. And the measure, denote the measure of angle AOB, this little m means measure. Measure and measure. Measure of angle AOB is the same as the absolute value of the difference between the real numbers for ray OA and ray OB. What that means is this number here, 140, is measured on the protractor. We start at 0, 10, 20, 30, all the way over to 140. So the measure of angle AOB is 140 degrees. So to use your protractor, here's an example one, and you probably will be able to borrow an orange one like this. At the bottom of the protractor is a line that goes all the way across, and it's above the writing. And then in the center, there's another vertical line that meets up, so it makes sort of like a T. What you want when you're using the protractor is you want the vertex or the end point that the two rays share to touch that point right there. And then you want to line up one of the rays either with the right side or with the left side of that bottom line on the protractor. So I'm going to measure this obtuse angle. I'm going to line the T up with the vertex right here, slide it on down. And if I twist the protractor, you can see that's the bottom line, and underneath, seeing through the protractor, is a line of the angle. I'm going to line up the ray so it's on top of it exactly. Then my ray that touches at the vertex and goes to 0, not to 180, but to 0, I can go counterclockwise until the ray touches my protractor again. So to me, this looks like it's just about 125. So it went 110, 120, 130, and there's a line in between, which is halfway between 120 and 130, which is 125. So I'm going to say this angle here is approximately 125 degrees. I'll show you an acute angle. This one is an acute angle. I'm going to take my vertex. This is my vertex, and line it up with that T. And I'm going to make sure that that bottom line, or the bottom line on the protractor lines up with the ray. And then I'm looking from 0, I'm counting up 10, 20, 30, 40. Here's the other ray coming through at approximately 45 degrees. Sometimes when you are trying to choose which ray to line up with the protractor, instead of it starting on the right side, it might be on the left. So here's my vertex right here, and I'll line that T up with it. And now my ray lines up with the left side of the protractor. And so the inner number starts at 180 and the outer number starts at 0. So I want to start at 0 and count up. So I have to go all the way around, and the ray continues on this way. And it's not 10 degrees because that would have been the inside number. You got to look at the outside, which is about 170 degrees. 170 degrees. Line up my vertex, line up my ray. This one looks like it's approximately 95 degrees. Line up my vertex, line up my ray. And this one looks like about 150. Wait a second, that started at 180 and I went backwards. I've got to go this way, 0 to 30 degrees. So I made a mistake on this one, so I'm going to come back because this looks like an acute angle, not an obtuse angle. So I have to start at the 0, and then it's not 95. That would have been if I was coming from the right. It's 85 degrees. So you should have a worksheet where you can try measuring your angles with a protractor as well for practice. Quick review. Acute angles are the smaller ones. So A is the point at the vertex. These two rays share point A. It says 0 degrees is less than the measure of angle A, which is less than 90 degrees. So an acute angle is smaller than 90 degrees, but it is bigger than 0 degrees. A right angle, it says we have this little box here, and that symbol means 90 degrees, or it means a right angle. It says the measure, the little m is measure of angle A equals 90 degrees. A right angle is exactly 90 degrees. And that symbol, when you have an angle in a little box, that little box is a symbol that means 90 degrees, or right angle. And that little sideways V is the angle symbol. Sometimes you'll see an angle symbol also with an arch in the middle. Obtuse angle is bigger than 90, smaller than 180. So 90 degrees is less than the measure of angle A, which is less than 180 degrees. Notice this symbol here is less than, and the angle symbol touches the bottom. So it comes down and it touches the bottom. That's the angle symbol. So obtuse is between 90 and 180 degrees, and a straight angle is, the measure of angle A is 180 degrees. Here's an example. The measure of that angle is a straight line. Postulate number 4 is called the angle addition postulate. The angle addition postulate means add angles together. So if they are put together, they're being added together. So in this diagram here, we've got angle RST, so I go from R to S to T. That whole big angle is also made up of two smaller adjacent angles, RSP and PST. So RSP is this inner part here, and PST is this inner part here. That's the angle. So we have two acute angles that make the bigger RST. The words of the postulate specifically say if P is in the interior of angle RST, so RST is the whole big one. So if P, so a point is in between the bigger angle, then the measure of angle RST is equal to the sum of the measures of angle RSP and angle PST. And in symbols, if P is the interior of angle RST, the measure of RST equals the measure of angle RSP plus the measure of angle PST. This means two adjacent angles. Adjacent means next to. Two adjacent angles make or add up to one larger angle. That's how I would say it in my own words. And P in the diagram is on the shared ray. And then you can write equations. We're going to be putting values in. So this symbol here, the measure of angle RST equals the measure of angle RSP plus the measure of angle PST. Let's say, for example, RSP was 30 degrees. And let's say, for example, angle PST was 40 degrees. How big is the whole thing? The whole thing is 70 degrees because 30 plus 40 is 70. So I would write the measure of angle, let me write it, I don't think you can see. The measure of angle RST equals the measure of angle RSP, let's theoretically say is 30 degrees, plus the measure of angle PST, let's say theoretically is 40 degrees. That means the measure of angle RST equals 30 plus 40 degrees, which is 70 degrees. Okay, two terms. Please write these down in your notebook. Congruent angles and angle bisector. Congruent angles are angles whose measures are equal. Measure means degrees. Okay, and we use measure and equal. So angles measure and are equal to. Angles, I say congruent, I think about that as shapes. So angle measures, this is degrees. So angles, if the degrees match, we say that the measures are equal to each other. So 30 degrees equals 30 degrees. But if I say angle A and angle B are congruent, those two angles, those objects or shapes are congruent, we say is congruent to. This symbol, it's like an equal sign with a tilde on top. That's the congruent sign. So you say is congruent to. That's the congruent symbol. In the diagram, congruent angles, this is angle A named by the vertex A. It has this little arch inside. So angle A, this little arch, and this little arch in angle B tells you that one single arch means both of the angles are congruent. So that's some of the notation. As long as the arches match, that means the two angles are congruent. So if angle A had two arches and angle B also had two arches, those are congruent. If angle A had three arches and angle B had three arches, that's another way to say they're congruent. You could even put a hash mark through it if you wanted to. Depends on how many angles you have. Okay, the next term is an angle bisector. First, let's start with the first word, angle. You should know what an angle is. An angle is made from two rays that share a vertex. There's the vertex right there. Okay, an angle bisector, the prefix bi, you could think of like a bicycle. How many wheels does a bicycle have? Two. So a bicycle has, that's a horrible bicycle by the way. Bicycle has two wheels. A bisector takes one angle and cuts it into two sections. So I'm going to cut it with a ray. It could also be a line. This is my angle bisector. Okay, lots of times we're going to see an angle bisector that is another ray. An angle bisector splits an angle into two congruent, using that congruent symbol, congruent angles. So an angle bisector splits an angle into two congruent angles. So I just told you if you have two congruent angles, you'd need a marking. So if this angle bisector cut this whole big thing into two angles, then this top half has one arch, the bottom half has one arch to denote the two pieces are now congruent. An angle bisector splits an angle into two congruent angles. So here's some practice. Name all the angle bisectors and the angles they bisect. Name all the congruent angles. I'll let you come back to this practice on your own. Give it a try. Pause the video. So how else would you know two angles are congruent? That's one hint over here. This says 42 degrees. Angle HEG is 42 degrees. Angle GEF is 43 degrees. Ray EG goes in between angle HEF, but it's not an angle bisector because those two measurements are different. An angle bisector has to bisect or split into two equal parts. No bisector here. Over here we've got 52 degrees, 52 degrees. Same angle measure, one ray in between the other two rays that make this outer angle. So RP, ray RP, is an angle bisector. So I didn't have congruent markings like the arches. At this time, instead, I had the degree measures. In this picture, looks like I got a little hint. I've got one arch with a hash, another arch with a hash. That's perfect. But an angle bisector is only going to be a ray. We've got this gap in here, so it's not bisected. So if I say that angle YME is my sort of outer angle, then I don't have an angle bisector. No angle bisector. And then part two, I want to name all the congruent angles. So I would name angle SRP is congruent to angle PRQ. Down here, I do have two congruent angles. Because there's several angles at one vertex, I need to use three letters. Angle YMN is congruent to angle OME. YMN, OME. Here's some more practice. Given that angle KLM is a straight angle, what does straight angle mean again? 180 degrees. Find the measure of angle KLN and the measure of angle NLM. So because it's a straight angle, straight angles means it's 180 degrees. That's a little hint. And now these two angles, KLN and NLM, are adjacent because they share a common ray. So we could use the angle addition postulate to solve this problem. It has an expression inside here to represent the degree measure and an expression inside here to represent the degree measure. So I can set up an equation. This obtuse angle is 10x minus 5 degrees. So 10x minus 5 degrees is the left one. And together with this 4x plus 3 degrees is a straight angle, 180 degrees. I could also write it like this. The measure of angle KLN plus the measure of angle NLM equals 180 degrees. So we're going to take this equation and we're going to solve for x. So take a minute and try to do that yourself. So I'm going to get rid of the parentheses because I really don't need them. I've got 10x minus 5 plus 4x plus 3 equals 180 degrees. 10x and 4x are like terms, so I'm going to combine like terms on the same side of the equal sign. 14x minus 5 and plus 3 are negative 5 and positive 3 are like terms, so I'm going to combine those. So negative 5 and 3 is negative 2 equals 180. I can add 2 to both sides. 14x equals 182. Divide both sides by 14 to get x isolated. X equals 13. Okay, number 4. Given that angle EFG is a right angle, find the measure of angle EFH and measure of angle HFG. This time, right angle. What does right angle mean? It means they add up to 90 degrees, or it is a right angle is 90 degrees. So I'm going to say these two angles make, here's my symbol for right angle, angle E, the measure of angle EFH plus the measure of angle HFG equals 90 degrees. EFH is represented by 2x plus 2. HFG is represented by x plus 1. Combine like terms, 3x plus 3 equals 90. Subtract 3 from both sides. 3x equals 87. Divide by 3. X equals, 29. Now, we needed to find the measure of the angles for both of these problems. So I found x, but I need to make sure to read the instructions carefully. So if I find x, I'm not finished. It says find the measure of KLN, find the measure of angle NLM, find the measure of angle EFH, and measure of angle HFG. So to do that, on the left-hand side, we know that x equals 13. And on the right-hand side, we know that x equals 29. All we do is substitute in and evaluate. So the measure of angle KLN is represented by the expression 10x minus 5, and we know that x equals 13. So 10 times 13 minus 5, 130 minus 5, 125 degrees. Two things I can do here. I can find the measure of angle NLM by substituting 13 in. 13 would go into that x, 4x plus 13. Or, since I know KLM is a straight angle, I could say 180 degrees minus the measure of angle KLN equals the measure of angle NLM. So this guy. So I could do 180 minus 125 equals the measure of angle NLM, which is 55. 55 degrees is the measure of angle NLM. Similarly, for number 4, we know x equals 29. I'm going to substitute in. So the measure of angle EFG is represented by 2x plus 2. And I know x is 29, so 2 times 29 plus 2. So that is 58 plus 2, 60 degrees. This is an easy one, x plus 1, so the measure of angle HFG is represented by x plus 1. I know x is 29, so that's 29 plus 1 equals 30 degrees. Or if I did it the other way, we have a right angle, which is 90 degrees. 60 plus 30 degrees is 90, so that's one way to check my work. Okay, we are in the home stretch here because it's time to give you your homework. If you have any questions, please don't hesitate to ask your teacher or stay for help. And I hope you enjoyed the video and that you can read it and it makes sense. Bye for now. This is Mrs. Blaylock.